Hello, my name is Bogdan Vera, and I'm here to talk about the development of player-driven audio tools for dreams. And I come from a company called Media Molecule, which makes video games. So what is Dreams? Dreams is a UGC game. That stands for User-Generated Content, and it's on the PlayStation 4. And it's in some ways a spiritual successor to a previous game we made called Little Big Planet, which also let you do similar things to Dreams. And that is make content with the same tools that we use to make the game. So the tools that we design for ourselves, the players also get. And you can make everything from games to animations to art to music to sound art and even stuff we haven't maybe thought of yet, because you can put all these things together in the same place and make anything you want. It's got a built-in social platform called the Dreamiverse, where you can upload your creations and instantly share and collaborate. So for example, if you make a piece of music, I can put it in my level. Or if I make an audio recording, you can put it in your piece of music. Or I can sculpt a tree or a rock and you can put it in your scene. So in Dreams, you can do a lot with audio. You can create and remix and share songs and sounds. You can implement game audio, so dynamic music and audio that's linked to game events. And you can produce reusable assets for other users and publish them to the Dreamiverse and collaborate on them. You can create interactive experiences that aren't just games, but you can make installation-style art or playable instruments that exist within the play mode of the game rather than the edit mode, so people can just play them. And you can link to the real world, of course, with the controller, because you can just do some mappings to the controller buttons. And you can record audio and share sound libraries with other users. And one cool thing is you can perform live music. You can just take your PlayStation on stage and use it as your main audio workstation for both audio performance or music performance and live visuals if you want to, because of course it's a game, so it does that. So here are some of the underlying principles that we followed, even from the early development of Dreams. The main one that always came up is flow. And flow is this idea that a creator or a performer can be in this state of mind where they're thinking about the big picture of what they're doing. For example, a guitarist who knows a song really well and is just playing, They don't have to think about the chords or like the shape of the guitar or maybe even the audience around them or the microphone they're using. They don't care about those details. What matters is the moment-to-moment aspect of performing. And that's what we wanted to emphasize in these tools, as opposed to an editor mentality where you go into different menus and stuff to do various things. We also wanted to emphasize performance, so the idea that, again, instead of going and editing things, you do stuff with your hands in some way, directly, like a performer would. And that doesn't apply just to music, but it applies to graphics and stuff as well. And even animation and stuff like that. Our characters are kind of performed via a form of puppetry. The other big principle that we followed was integration and generalization. So the idea that your animation tool can be the same thing as your audio tool, can be the same thing as your logic tool. And we did do that, and I'm going to talk about that in a bit. And very importantly for Dreams, we didn't want to just go make another audio workstation, because there'd be no point. There's other ones already. We wanted to make something that feels cool and fun to use with a controller on a console from your sofa, but that we can also use to make our game to a level of quality that we'd be satisfied with. So basically the challenge there is to create a fun game that you can play on your couch that lets you also make entire original games and also great music and audio, which sounds basically impossible. And yeah, it was a good challenge, and I think we gave it our best shot. So some examples here of other things in the game that follow these principles are things like the fact that we don't use polygons for our models. In other games, characters and levels and stuff are made out of polygons. Our models and characters and stuff are made out of just sculpted signed distance fields. Basically, the users just use the controller and they move around in 3D and they sculpt these shapes. They don't have to think about the vertices and the normals and all those things. And we don't use textures because, again, like mapping bitmaps onto polygons is a very technical thing. So in Dreams, you kind of just go and actually sculpt in the details yourself with the controller. But you can also use these tools that we've developed to quickly achieve a certain aesthetic that fits with the game quite well. So with a couple of movements of your controller, you can loosen up these sculpts to get these impressionistic painterly effects, which give it a certain visual identity. And the UI itself had to be simple, but also powerful. And we wanted to avoid what we call overflow menus, which are these menus where you normally, like when someone asks you for a new feature, like the polygon normal inversion / slicing tool, you go and put that into the menu somewhere in this overflow submenu where you shove all your features. And we wanted to avoid that because we didn't want to have all these menus everywhere. So in many cases, when someone asks for a feature like that, we either said no, or we found a way to combine multiple other tools to be able to achieve that effect. So maybe in the case of the thing I just mentioned, you would do a certain gesture with your controller in a certain state. But it was difficult to apply similar ideas to music and sound design. And the problem is that most people, even children, would understand how to draw a stick person or a tree or a house. They have this innate understanding of what a house or a person is shaped like, but people don't have an innate understanding of what music is shaped like, because music is this abstract internal representation of something quite logical, which means it's hard. There's no way you're gonna take someone through the whole process of understanding musical theory to make a song. So we had this issue where, it was just a bit too abstract, and we had to figure out a way to bridge that gap. But there's also this issue where people feel this reverse elitism, where they feel like this is just not for them, not even gonna try. It's for someone else who knows how to make this kind of music. Maybe they'll feel like it's something they'll be judged for if they make something and it's bad. Whereas people who normally play video games, video games have challenge, but you're not gonna be publicly embarrassed over a video game. So when I came onto the project, we had some audio in the game, but it was all in these kind of debug technical menus. And the thing that was missing was the tool set, the interactive aspect of it. And a lot of ideas were being floated around. People kept saying stuff like, it's got to be playful, and maybe you jump on mushrooms, and the mushrooms make notes when you jump on them. Maybe you can play the level, like say if I open a door, instead of squeaking, it makes a melody or something, and I can move the door back and forth, and it would do that. Or that it would sound dreamy, this dreamy aesthetic. What that means, nobody could really explain. But to the audio team, it kind of maybe implied some sort of granular, scrambled, reversinated sort of thing. So there was an ethos there, but it was quite vague. And basically, for me, it was a matter of figuring just something out to do. And on the PlayStation, you have to remember there's normally no keyboard and mouse input, so this whole thing must be driven with the controller. So you've got either the DualShock controller, which is a motion-driven thing where you can point in kind of 2D space like a laser pointer, or you've got these move controllers that you can move around in 3D space. So basically, if you can sculpt trees with a controller, why not sculpt music, is what I was thinking at the time. So those early prototypes were inspired by what we could do with the sculpting and art tools. And for me, motion and shape was very associated with kind of Xenakis and stuff like that, like the idea of graphical scores that, encode music in a more visual way. And I thought that was cool because everyone can kind of understand movement, shape, and color, but they maybe don't understand musical theory. So, hey, maybe we can make it so that the music is expressed in shapes and colors, so people just think in those terms somehow to make music. Remember, this is for like everyone to be able to make music, not just for sound designers and composers. So basically, it's kind of rephrasing complicated music theory as this other hierarchy of parameters. And, because we have motion control, of course, motion-based music of some kind would have been a cool idea, is what we were thinking at the time. So a lot of these early ideas were stuff like, hey, maybe you just draw these curves, left to right, and maybe you map pitch on the y-axis, and the x-axis is time. And you have this kind of classic graphical score thing where maybe these curves get thicker and thinner to represent volume. Maybe their color is different instruments and stuff like that. So, quite simple stuff that you might see at NIME or something. And then it evolved into this thing where, like, maybe you just draw these shapes in a 2D space, and maybe time isn't an aspect of it, because we found quite quickly that people struggled with the time aspect of music. And by that I mean beginners or people who don't normally make music struggle to keep in time and play beats. So maybe you just draw these shapes and the game somehow does timing for you, so you just care about textures and stuff, so you make soundscapes and kind of avant-garde music. But the problem with this was that it was really academic, and the thing is, even though you can make these soundscapes quite easily, and everyone can, it's not everybody wants to make abstract avant-garde soundscapes. People want to make dance music and stuff. And the other issue was that the content team that we had said, no, I'm not using colorful blobs to make our AAA game soundtrack. There's just no way, basically. So this abstract, like, post-tonal music thing was around for a while and then went away. But some of this stuff remains today, and you'll see that in a second. This 2D colorful blobs thing, it's still there as a core aspect. So basically, at this point, there was this serious dissonance between needing to make a fun audio tool for gamers and also making it powerful and efficient enough to actually make a AAA quality audio experience on there for our actual content. And of course, we have to use the same tools as our players, and we can't just ship a DAW either. We can't just ship Fmod or Wise. It's not something we can do. And why is that? Well, that's because we're a small dev team. Like, at most, we had 2 audio programmers between me and Alex Evans, our tech director. And we don't have the audio memory availability that you might have on a PC where you load gigabytes of samples. We just have, like, whatever's left after the game has allocated its resources. And then you'd have to tutorialize it, and it's not fun to sit on your couch and use a DAW. You want to do that at your desk. And a lot of other reasons. So at this time, there was this kind of terror deep thought thing where I just didn't quite know what we can do about that. Maybe it was impossible. But a game audio tool needs a couple of things, and you kind of need these things to really get away with it. And you need, obviously, sound playback, some way of managing assets. So what are your samples and stuff? You need sequencing, so time, linear sequencing, and also dynamic sequencing. Implementation code of some kind, so maybe linking game events to things that happen in the audio engine. Spatialization, localization is a big one that we didn't think about enough at the beginning, which is different languages and translating voiceovers. And mixing, these are things that you need, and we actually did need all of these things in the end, and we had to make all of these available to our users. So yeah, were gamers going to be doing all of this on their PlayStation? That remained to be seen for a long time. The thing that really solved all these problems for us was this concept that we eventually came up with called an effect field, and this other thing called a soundstroke. And a soundstroke basically is one of these 2D space trajectories. It's the same thing as before, where you draw with your controller from point A to point B. But we added this other thing called an effect field, and what that is a object that lives in this 2D space and has a central position, an inner range and an outer range. And it's effectively a form of preset interpolator, where your stroke is a synthesizer with a million different parameters. And as it goes into this effect field, the effect field asserts a change on those parameters. And they can blend with each other as well. So basically, you can now perform through this 2D space, not just with pitch and velocity and position, but with all of the parameters in the synth at one time. You can do these massive transformations. For example, I can have an effect field that applies 10% to volume, 50% to time stretch, minus 30% to grain length, and so on. And now I can go in and out of that field, in time with the music, or according to some expressive curve I want to get. Or I can go, between 2 effect fields to get a wobble or something like that. So in a way, it makes fairly advanced concepts like automating a dubstep wobble or freezing a sound granularly a thing that you can express just with these colorful shapes. So a user might think, hey, how do I get that creepy ghost voice effect? Well, I stamp down the creepy voice effect field, and now I've got not just a static effect that's applied to my voice, but I can perform in and out and get these different transformations. And here on the right, you see this freeform view where these strokes live and the effect fields that they go through in this case. And the cool thing is these strokes also exist in time versus pitch domain. And on the left, you can see that, and that's just the piano roll. And each one of these corresponds to one of the notes in the other view. And they can transform from one to the other with a lerp, effectively, like an animation that shows you where all of these notes go in the other view. And you can do stuff like select in one view and edit in the other view. So basically, these sound strokes are stored musical data that exists in this 2D space, while also containing some temporal data. And every single one of these strokes is related to a single voice, which is a full synth instance. So there are other preset interpolation schemes out there that are really cool, where normally you have a synthesizer, VST or something, and you interpolate between the different presets using a little positional knob thing. And as you go between them, it lerps the synthesizer together. In our case, each one of those strokes is an individual synthesizer. So in the same instrument, I can perform in different parts of that space and have totally different sounding strokes, and have all this blending going on. So it's kind of cool because you can kit bash with these effect fields. You can make your own and publish them for other users, and it just makes you think differently. It makes you not worry about animating automation curves, but more about how can I perform, like I said before, with my hands to get these expressive curves. Because like on a keyboard, for example, if I want to apply an effect, I have to basically play with two hands on the actual notes and maybe move a dial or a slider or something with my other hand, which means I need to take my hand off the keyboard. In Dreams, you can basically perform all these notes with the controller buttons, but because you've got the motion at the same time, you can do these massive expressive transformations at the same time. So it's another aspect of the performance you can do. And you kind of, with practice, develop techniques naturally, almost as if you're practicing them on an instrument. You can basically get sort of like extended techniques for the controller instrument in a sense. And it lets you do really fun things like, for example, applying programmatic 2D offset to these performed strokes. Once you've recorded them, maybe you take a wire from a character moving in the scene and you map their velocity to X offset. So now your strokes are moving in and out of certain effects. So you can do dynamic music or sound design in that sense. You can apply LFOs on field strength. So you can have an LFO that kind of pulsates the effect field in place. So now when I play in that effect field, it's doing something rhythmic. It's basically applying the interpolation with a varying power. Or you can put these effect fields in the world. They can live with a spherical zone. So now when the character goes into these effect fields, it can be affected in some way. Its sounds, its footsteps, or its voice can have a certain effect. And it was very important for us that these effect fields can become as general as possible so that there aren't many other ways to do this. We wanted to have them as a primitive aspect of the system, which is why we gave them so many different aspects. They live in 3D, they live in timelines, as you'll see, they live inside freeform view. You can drive them with wires and logic, you can do all these different things. And in terms of how you perform, how you actually get input into the game, you use the DualShock controller or the Move controllers. And basically you just use the front 8 buttons to play notes, and they're locked to a scale. So you've got one thumb for each, kind of like a kalimba, I guess. And you can tilt left and right to get octave shifts. You can use the touchpad to do semitone shifts and bends. And R2 is analog volume. So you've got 2 thumbs on the main buttons, and your index fingers are controlling the 2 triggers, so R2 and L2. And they do expressive analog things. But of course, you've got now this extra 2D pointing thing, where while you're performing notes, you can also perform all of these transformations. So this kind of turns the DualShock controller into an instrument, where you can become a virtuoso on it in some sense. And it can take a while to master. It's not easy to be really, really good at this immediately. You have to understand how to play it and then practice scales and stuff like you would on a normal instrument. And you can do really interesting extended techniques and quite advanced concepts. Like if I was going to explain granular synthesis to a 10-year-old who's never done music or sound design before, I would have to explain to them all of these, what are grains? How do they overlap? What's a grain interval? How many grains are playing at one time? How do you get it to be in time with the tempo? In Dreams, you just get them to stamp down these effect fields. And once they've understood those effect fields, they can also go tweak them in their options, in their settings menus. But they can get they can do things that advanced composers do with VST plugins just by kit bashing these effect fields together. And they might not know that what they're doing with this like granular synthesis engine is actually quite an advanced thing that you learn in your master's degree or something. And basically sound effects in VO as well are all internally playing these sound strokes, which again are another primitive aspect of the system. And these sound strokes can be also put through the same process of a positional parameter blending thing. So even when you're hearing just someone's voice, it's actually one of these sound strokes that's bunched at one position. But you can do stuff like use the controller to blend together different sound effects and record expressive sort of gestures through sound effects and transformations. You basically do sound design almost as if you were in a sort of virtual Foley box. Here on the right, you can see the tweak menu for a sound, and this is the Granular page. And this shows an interesting thing that we also implemented that I think would be awesome to have in other tools, which is that each one of these sliders isn't just a single value. They all have ranges, and what these ranges are basically randomization ranges. So for example, for the top parameter, whenever the sound will be triggered, it'll pick a value for that parameter between those 2 points. And you easily set that by holding down the button on the controller. So when you drag a slider, you hold down are equivalent of shift and then drag the slider, and you can make these ranges. But some of these sliders you can see have like these crosshatch diagonal patterns on them, and that's what we call spiciness. And spiciness is another range you can set on the slider, on the same slider, by holding down a different shift button, which is L2, the left trigger. And it's a range where from then on, whenever I hold down L2 during performance, all of these parameters will blend to. So I can easily make these sounds that have widespread randomization on all of their sliders. So whenever I press a note, it'll be totally different and varied. But then if I start pressing down L2, I can blend the entire sound to a different parameter set. And I can do that as I'm performing and also record that transformation. So in a sense, it's almost like an effect field applied to your sound, to your L2 button. So I think this randomization thing, I don't know why we don't do this in other systems. I guess it's because most synthesizers as plugins generally pull their parameters for each voice from the same set of parameters, whereas we have independent parameter sets for each voice that is playing, so they can be randomized on a voice-by-voice basis. So as I was saying, these two-dimensional positional strokes can also be viewed in a time versus pitch piano roll, and it does this lerp between them. And it lets you do this cool sort of workflow that takes a while to get used to, but is actually very powerful, where you can basically stay in freeform view for this more flow-driven mindset and go to the piano roll for this more editor-driven mindset. But because it's easy to switch between them with a button combo, you can do stuff like record a note in freeform view and then go to piano roll mode and just clone that multiple times to write your composition. Or vice versa, you can make something in the piano roll view and then take some of those notes, a sparse set, and then put them in other effect fields in the freeform view. So mastering these two views is a big part of how you make sound and music in Dreams. And what this does basically is it lets you playfully do automation just with the controller. So in essence, it's a system heavily colored by the tech that's available, which is kind of opposite to what we normally do, where we come up with aesthetics and then tailor tech to the aesthetics. In this case, we had the controller, we had some limitations. We didn't treat them like limitations and just made do with what's there. We really we juiced everything that's available to get all of these features and tools that wouldn't work on with other control inputs. And ultimately, this means that these music and audio synth techniques can be explained to some users. We have a couple of tutorials. They explain how to draw these curves and stuff, and people do them. It's quite easy to make both avant-garde stuff and also kit bash together some sound effects and instruments to make a dance track or whatever. So now we had this system for performing music and doing sound design on a low level in this kind of flow performance-driven way. But what was missing was the audio workstation aspect of it. And in an earlier version of the game, we had this mode you would go to, the audio mode. And in that mode, you would do audio and music, and you couldn't relate at all to the other tools. But what happened in the end is the animators were developing or designing a timeline for the animations, and the logic team were designing a timeline for the logic that they would do, like lights turning on and stuff like that, or character, AI or something. And we were designing a timeline for the music, and the obvious thing to really do was to just have one timeline that does all of these things. And that's what we did, and it's just called the timeline gadget. So basically in this final rewrite of Dreams, we integrated the audio engine with the logic timeline to kind of very organically function as a DAW with all the underlying playful features that I showed before, grinding away underneath within the inner elements, the sounds that you put onto those timelines. And it was not easy to do. It's I know how to make a sequencer for MIDI or audio. I think everyone does. But it's tricky to communicate with the other teams within the development team to let you integrate all these specialized subsystems with the rest of their tools. Because obviously animations, for example, run at game rate, whereas audio runs at audio rate. And audio team needs certain features that maybe would kind of be annoying to animators if they were just there all the time. So there were always these caveats of like, hey, we can't have some of these things because they would influence negatively the rest of the team. But the best thing that came out of this was finding features that work for all of these teams and really hanging on to those ones. So in the end, the system only became fun when this tool unity was achieved. There's no separate editor for animation or audio. There's just one place. You know, you make music in the world next to your logic, next to your trees and other things that are in the level or whatever, characters. You never have to change scopes or creative domains in any way. And basically, this all works with the controller motion input, like we needed it to. And it's got this consistent input metaphor. Again, the way you sculpt things is by flicking your controller around. The way you make music is by flicking your controller around, and same for animation. And that helps achieve this playful, performance-driven approach. And as I said, audio and music and stuff all exist in the same system in real time. It's no compile times. It just, you hit play and you're in the level and you're playing. And you can edit it while it's playing. There's no export step of any kind. And all this fast prototyping generally leads right into development, so everyone's kind of liberated to create. Like I can make a prototype or a test project that ends up being the thing that we actually ship in the end. There's no, in-between version. Here's an example of like what a timeline looks like with different things in it. You can see like just some music clips, like kind of MIDI style. Remember, those are the individual sound gadgets, which inside have the squiggly stroke paths and stuff. But there's also some animations, and like there's a nested microchip in here, which is like a sort of sub-patcher that contains some logic. So you can put, for example, a microchip full of logic at a certain point in this timeline, and it'll trigger then and do whatever logic is inside. So it's kind of cool because you can take this timeline, which is effectively our DAW, and you can nest it within itself, so you can have nested clips within clips within clips. And you can also have microchips, which contain further clips, and you can infinitely nest them. I don't know of any other audio workstations that let you do this sort of clip nesting, but it's actually quite powerful and lets you do some fairly complicated setups. And we have to propagate playheads down this kind of tree of nested things. As for the Dreams audio engine itself, its main features are basically every voice is fully granular, always. And that's kind of our second big miracle. This is what we decided early on would define the sound of Dreams. It's that at any point, sounds in the level are ready to be stretched or scrambled or like frozen in some way. And even if you hear someone talking in the game or you hear a sound effect playing, it's always granulating, even if you can't actually tell, because the grains are normally overlapping perfectly. That means that basically it's always so easy to do these dreamy effects that we use them loads. It just colored the way the sound is in the end in the game. So our main content, our main kind of story campaign is full of these granulated soundscapes mixed in with kind of jazz and other stuff like that. But of course, because it's fully granular and it's always granulating, it's quite expensive. It's cheap to like stream in some audio and then just play it back on an audio channel, but we're always doing this granular stuff. And it's written in pure scalar C, which sounds like it would make it worse, but it turns out that you can write stuff in C without manually using SIMD intrinsics and stuff. And a good compiler, for example, Clang, will mega optimize scalar C to the point that we tested it against writing SIMD instructions, and it was as fast, if not faster. And it's just simpler, and it's easier to understand. So if you organize code the right way, you can get away with just compiler optimization. And basically, in terms of the capabilities of the sound engine and what you can do with it, we tried to get as much juice as possible out of the granular synthesizer. So we use that a lot to get our sound, as opposed to big sound libraries. It's rare in Dreams to have a piece of music that uses gigabytes of sound samples, because we can't afford it. So we have to rely on getting cool sounds out of the synthesis we have. And the cool thing about Granular is it's comparatively cheap with other timescale manipulation methods like phase vocoders and additive resynthesis and stuff like that. And The other interesting thing is the music, of course, is always live in Dreams. It's never bounced down to a track, which means that if I play your level and it contains some music, that music is playing live from the symbolic data that was stored, that was created by the original user. And you upload these creations to the cloud, and they're stored on our servers. And the audio samples that you potentially import or record are compressed in the level data, but we decode them on level start into just raw PCM. In most games, you can get away with streaming chunks of audio as it comes in, as it's needed for the music, for example. But in our case, because we're granulating and the playhead of the audio voice can jump to any point of the sample, we need to have the sample in memory pretty much at all time. We can't on-demand decode stuff. We probably could, but it would be quite tricky, I think. But the cool thing is songs that are made from our own instruments that come with the game are all on the disk. The actual sample data is on the disk. So if I play a level that you made, I never have to download hundreds of megabytes of audio samples. But I can still hear any music you made because the samples, I already have them. Which basically means, combined with the way we store our sculpts, our level data in this sign distance field representation, it means that basically our levels load extremely quickly, even if they have complicated music. And the way the audio engine is organized basically is there are these things called sound gadgets, which are the game level representation of a sound, and they update at 30 hertz from the game, and that includes the playhead updates from a timeline, for example. And we basically send to the audio thread at the end of a game update an entire copy, or rather a handle to the game that contains this sound gadget. And then on the audio thread, basically, these sound gadgets spawn individual audio tracks, which are kind of a sounds instance on the audio thread. And those update at buffer rate, effectively. They update their playheads, and they do 3D panning. And then each audio track can spawn multiple voices. And each voice is like this stack of effects. They're always there. And these are the things that correlate or relate to the strokes that are wiggling around in the freeform view and reading out effect fields and stuff like that. And then each voice spawns out individual grains. And interestingly, our signal flow is quite unusual for an audio workstation, because normally in a workstation you have a mixer and inserts and stuff. But we have a fixed pipeline where voices always go through these effects, which you can toggle on and off. We have sends to 4 reverbs, which are IR reverbs, and 4 delays, which are just there in the sky somewhere. And then we send that. We also send out to panning and ambisonics for each voice. I guess that's done at the track level in the end. But yeah, interestingly, we don't have a mixer UI anywhere in the game. And I wrote here that mixer bad, but it's not that mixer is bad. But I think when you got the opportunity to make a new UI, a totally new interface, why go for something that's so old-fashioned when something that's kind of free form and kind of patching based is as powerful, but maybe easier to understand for some people, because not everyone has necessarily grown up with mixers. Someone who doesn't have an opinion on whether you need mixers or not might not care that there's no mixer in this game if they understand how to use this particular way of routing signals. So I have here some notes on logic programming as well, which is just talking about how Dreams handles effectively like programming. How do you actually make these games, and how do you interact with the music? And the idea basically is that programming in Dreams is done with these things called gadgets, which are these kind of data flow style boxes connected with wires, very similar to like pure data or something like that. But the cool thing is every parameter of every single one of these gadgets is exposed to wires and animation. So for example, timelines and music and sounds are all gadgets. So I can take a wire from any game parameter into any parameter of the sound in real time. Like maybe I can plug a character's walk cycle position to granular stretch or something, or plug into one of these effect fields and do like a big multi-parameter transformation. But the game update basically is we just topologically sort these gadgets based on their wires, and animations that also drive these parameters also use these invisible wires. So we can sort the whole scene so that with them we can run in order over all these things. And all we do is we take an old game that has all the state from the old frame, and we just turn every single thing into a thing from a new game. And at the end of this, we have a game, and then the audio thread takes a handle to that old game, and all the state it needs is there. Like if the audio thread wanted to iterate over, over all wires or something, it can thread safely do so. because we never touched the old game at that point. And so does the render thread. And then the game thread will never read data from the other threads. There are a few exceptions, but we can't actually read the audio thread data because of determinism needs we have on the game update thread. And everything, which includes gadgets, which are things, has a unique power input that turns things on and off. So, for example, on a light, the power will be its light brightness. On a character, it might be visibility or something. On a sound, it's volume. But with the same input for volume, we detect edges. And when you turn power on, we just trigger the sound. So we detect these power edges. And the cool thing about using this generalized concept of power, which again is this kind of primitive thing in Dreams, is that we can use power. We can take aspects of how sounds work and put them onto other gadgets. So for example, lights have fade in and fade out, just like sounds do, because we needed fade handles, like in any audio workstation, on the sounds. But because we did it with power, it doesn't have to be a special sound thing. It can just be a power fade on pretty much anything. Animations, keyframes. And have some notes here on anti-creep, because as you can imagine, through all the development of this project, you've got all these teams that are asking for features continuously. Remember, they're not using their normal tools. Imagine a team that makes a game that is used to using other tools that they would normally use, that are now making this game entirely with their controller on their PlayStation. They're not using Windows, they're not using an audio workstation, they're not using a 3D modeling program. They're just making everything in the game. They want everything they're used to. So basically, we had to learn to aggressively say no. And I think that was actually very important. And you might say, well, saying no to all these things means you end up not having all these cool features. But actually, if you say no enough, you can postpone things until you can figure out ways to combine those requests. So once you've got 10 requests that from the team, you can then match them up and say maybe these three features are the same one with the same tool. And again, as I said before, like avoiding these overflow menus, not shoving features into drop-down boxes. So now we got to talk about the bad, like what were the weakest points of our approach. And really the weakest points of this tool set are whenever we interfaced with external tools. Like whenever we were like, oh, we know how to do localization or audio pre-processing, we'll just use those tools instead of making our own tools. That's where everything was slowed down and annoying. And generally using our tools to make a level and make some audio for it is like fun and you're in the flow. But then when you have to go reach out into some other batch processor in Windows, that's basically, it shows why it's so much better to work with an integrated system. And if we designed those tools the same way as everything else we designed, it would have been much better for us, I think. But we fell into that, oh, we've done it before, we know it's fine. Like a sound designer for a game knows what they've used in the past. They think they can just use that. In our case, that was bad. Probably in other people's cases, that's great because they can just transfer their skills. But yeah, we left that a bit too late. And the game does have localization. Players can localize their own audio, but we were making a huge amount of content with a huge team, and there's a difference between one person making a game with one translation and an 80-person team making a game with 20 translations and VO in every single language. So with this talk, I kind of just wanted to give an overview of what we did and the challenges that we encountered. And maybe also talk about some neat ideas that other people might find useful in their own projects. But I also want to give some takeaways as well. And the first one is that putting aesthetics before tech design can be a great way to work. You can be sometimes liberated by limitations if they serve this creative flow. It's useful to basically pick an aesthetic and then narrow down what you need in terms of tech for that aesthetic, as opposed to going and picking something up from the shelf and just using something that's very broad, where you have to contend with all the things you don't actually need to use in the UI, and constantly butting up against that. I think also making prototyping live inside the main tool is great because it just cuts down on time and again keeps you in that flow. Integrating tools as much as possible lets developers be more expressive. Like I said, in our system, if an animator encounters an audio bug, they can just fix the audio bug. Like if the audio is a bit out of sync or something, or even if it's too quiet, or like something's happened with the sample, an animator who's working on a walk cycle or some facial animation or something can go and just poke that and fix it and publish it. Whereas in other games, they'd have to go probably ask the audio team to open their implementation project in a different tool, and then so, and vice versa, like our audio team is quite well versed with animation, so they can happily help with something being wrong with the way the animation interacts with the audio, for example. Shape and space is a great way to not just visualize but implement sound. I think it's just fun to try new ways to work, especially if you have to work with a constrained input method. But I think this preset interpolation approach to sound design is a unique way to approach that. I think it lets you treat sound design more like performance and just makes you think differently. And it's just more fun than fiddling with sliders and knobs and dials. And also, ultimately, that music and audio tech can be fun for a very wide audience if we can find the words and metaphors to popularize it. And I think it's worth thinking here about the fact that music can have a varied hierarchy of parameters. We think of music as normally having rhythm and tempo and harmony and pitch and timbre. But you can make reduced hierarchies of parameters where, hey, you know what? This system makes music that focuses on rhythm and pitch, or this one focuses on timbre and music and like movement. So you can think of ways to basically just make it approachable for people to make music by reducing the number of things they need to think about. And that's something we tried to do. In the end, our system is still quite general. It can do all of those things, but because it's rooted in those original prototypes that focused on textural stuff, it just has a certain vibe to it now that really leaks through all the time. So for the future, the tools are now in the community's hands, and we have endless mountains of feedback to go through. It's a bit like in the earlier days when we were still developing the tools, when we had all this constant pressure from the team to add more things. We have to do similar triage and try to combine feedback to get to result in actual useful features that don't result in feature creep. But yeah, we're going to add audio import. We had audio import at one point back in the early access, but it just needed more work. And eventually, I think it might come back. Audio export will be coming eventually, I hope. I mean, these are just things that are on my mind more than anything. Sample packs definitely coming. Our team can just dish out sample packs continuously, but also the community is making samples, so it's kind of a weird thing where like, what else can we possibly give the community they can't make themselves? OSC support is already in the game. You can drive the game's audio tools with OSC just in terms of playing notes and driving spiciness, that L2 parameter I mentioned earlier. But we are working on some fun stuff for the future. And one thing I've always wanted to try, and I think eventually I'll get a chance to look at this again, is just AI and MIR sort of music analysis. The cool thing is, because our music is all symbolic, it's just a goldmine for just analyzing and generating. So we can make systems that maybe help you compose or help you write or fix your tracks, or recommend music for you based on the actual symbolic data that's there. And one thing I'm really super hyped about is Dreams on a stage as a stage instrument. So we've actually done a couple of concerts with Dreams at game shows, and I've taken Dreams on stage on my own as well. And the thing I really, really like about it is that I can face the audience, and behind me have my actual screen where I'm working, and just show the audience everything that I'm doing. It brings back that missing aspect of kind of laptop performance where you don't know what the artist is doing. With Dreams, I can fully sort of broadcast my process. And it doesn't look like, a tool. It almost looks like a game. I can have visuals and stuff in the background behind the actual tools I'm using. So yeah, thanks a lot for watching this. and please get dreams and make tons of stuff in it. So yeah, thanks, and I'll be taking questions now. So yeah, thanks a lot for watching this, and please get dreams and make tons of stuff in it. So yeah, thanks, and I'll be taking questions now.
Yeah, thank you so much for this talk. Can you hear me?
Yeah, we can hear you.
Yeah, thank you so much for this talk. I'm absolutely blown away by this. I have not, seen this before. And I was just watching your talk, and I have literally on my desk like one of these things just like lying around just now, and I was kind of imagining, things I could do with like this game. But then unfortunately, I'm looking in front of me, and there's like a screen, and there's a door, and there's a bunch of plugins, and I'm pretty much stuck in that paradigm. It feels that we are kind of missing out on a lot of creative tools by being stuck in this world. So, but I'm wondering, is there anything? Do we have any plans kind of to port this to other platforms, to like give something to people who are maybe not kind of in this ecosystem of like a console, more like on the kind of traditional side of things of using music like in a DAW?
Hey, can you hear me?
Yep.
Yeah.
Awesome. There's no plan to bring it to any other platforms like Windows or OS X or anything. It's always, for now, it's probably going to be on the PlayStation. But the thing about the PlayStation is it kind of becomes a replacement for your PC in this sense. And I don't think we set out to make an audio workstation. We didn't want to replace Pro Tools for anyone. It's meant to be a separate thing that works a bit differently, that puts you into a different mindset. So that's kind of how I think about it, basically. But for example, we've used it to set up installations where we just, instead of leaving a Mac somewhere, we leave the PS4 and it just runs the game, just visuals and audio and stuff. So I think that's how I think of it, basically. But I mean, you can also, there's no tool in the game to export the audio to a WAV file, but you can easily just share and record your screen and export the audio from that. And in many cases, people like to attach visuals to their music because doing visuals in Dreams is really fast. So generally, the things you consume within the game are not just pieces of music, but they're more commonly audio-visual experiences. If that makes sense.
Yeah, thanks. That makes a lot of sense. So how can I check this out?
You just have to get a PlayStation and buy it.
All right. Yeah, I already have the PlayStation, so I guess I need to check out the game now.
But I mean, compared to an audio workstation, it's probably a fraction of the price as well. I mean, it's the price of a normal game on a console.
Thank you.
Yeah, so I had a quick question from Alina Amasan. Who actually came up with the original idea for how did it actually come into conception?
For the whole game?
Yeah.
I don't think I could tell you. Before this game, we made something called Little Big Planet. In that game where similarly you could make anything you wanted. You could make games and you could make music, but mainly you could make games. And I think Dreams was just an iteration of that, adding more disciplines, basically, beyond just making games. I couldn't tell you where exactly the idea came from, because I started halfway through the process. But I think the team just kind of naturally evolved towards this shape for the game.
I have one more question as well. What's your background? How long have you been working in audio or in development, and how did you find your way into this particular area of development?
So I came to the UK in 2008 to study music tech, and I went to Bournemouth University, and I did my bachelor's there. And I did a music tech Master of Arts at York, and then I started doing a PhD for a while, but I quit that. And I think I just kind of like applied for the job and got it. But during that time, I just did lots of little kind of side projects and stuff that I used to post on my YouTube. I mean, I'm a musician as well, so for me, programming and music kind of live together in the same part of my mind in a way. And I've always liked making tools just to aid myself with music, but also now to aid others, basically.